Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. Hello, everyone, and welcome to the Fabrication Friday podcast. You're back with Joe Fairley here, your host, certified prosthetist, owner of Ascent Fabrication, and overall 3D printing enthusiast. So this week, we're getting right started with our new series. You might have heard last week, I did a print of the week at the beginning of the podcast episode and a tech tip of the week at the very end of the podcast episode. So if you didn't quite hear that, at the end, definitely go back and take a look at the end of the podcast, as well as this one for our tech tip of the week. So this week, we're going to be highlighting a Fast Flex, that's our name for it, the Fast Flex below knee TPU flexible inner socket and the polypropylene frame. So the Fast Flex here is a 3 millimeter thick, very lightweight, and if you're in the prosthetics industry, similar to ProFlex material. We printed a fairly low layer height for this at about 0.4 millimeters, so the feel of the socket is pretty smooth. This socket was printed on the Artillery Sidewinder X2, so a $300 printer printing out a very substantially durable prosthetic interface in about 5 hours and 45 minutes with a 0.6 millimeter nozzle. So fairly nice results. I spoke wrong. I think I used a 1 millimeter nozzle on that, not 0.6, so to get that 5 hours and 45 minute time. But the polypropylene frame was printed on the Filament Innovations Kratos. The Kratos is the little brother to the Icarus. The Icarus is their main, I'd say, flagship printer at this point for the prosthetics and orthotics industry. There's a lot more clinics coming around that are utilizing this printer. And this polypropylene frame from the polypropylene itself was from PP Print out of Germany. This print was done in 2 hours and 1 minute. So after just less than 8 hours, you have both of these sockets, very low cost, lightweight, and dare I say, definitive. We'll get into that a little bit more as the podcast goes on here, maybe a little bit with Bartosz. But to introduce Bartosz, so thank you very much for coming on today, Bartosz. Bartosz is the CEO of vBionic. vBionic in Poland is doing some really, really cool things in the prosthetics industry for upper extremity prosthetics. We've worked with them a lot in the past with some custom silicone liners. We've having great results with that too. And Bartosz has a lot of just general 3D printing experience, so we're happy to have him on. So thanks, Bartosz.
Hi, Joe. Hello, everyone. I'm happy to be here today and maybe share some thoughts and ideas about 3D printing as well.
Yeah, absolutely. So when did you get your start with 3D printing?
Oh, honestly, it was quite a long time ago. I guess like 8 years ago or something, just when the technology emerged from the limited and corporate rooms and rep surfaced, and we could start using it. A friend of mine, he had the very first commercial printer, Ultimaker Zero or whatever that was, the very first one, and it was pretty costly at that time. But the first moment I saw a Duplo Lego brick coming out of it, I knew this is something, I need to have that. And being an engineer, then the next thought was, I'm not going to buy one. I want to build one, of course.
Right.
Because buying is simple, but buying 3D printer is not that simple, and assembly also is not that very simple. Anyways, I just wanted to have one on my own. and then the time there was no obvious solution at that time. I went to for a very for a solution that did not work in the end. But I wanted to have a bigger bed, so the bed was big, but it was moving in one direction. There was a project, open source. It was on Kickstarter, honestly, but the files were available. So I printed parts on my friend's printer. It was also so cool. You can replicate the 3D printer on some other printer. This idea was like mind blowing at the time. So that was the first time. And I did a lot of mistakes from the very beginning. The first and biggest mistake I did was for some unknown reason to me, I really tried to start with ABS filaments. And I don't know why, and nobody knows. And that was a very big mistake because, ABS is maybe cool, but it's not that popular due to some problems that you may have with the ABS. And I did have a lot of problems, not only with the printer, but also with the filament itself at the very beginning. So it took quite a lot of time. And well, that was the start. And then I just knew I want to get involved into that, do something, some real objects, something that you can touch, feel, and be useful in the end, because printing the benchy boat is not the, the top of what you can get out of the 3D printer, don't you? So
Just
so
another
yes,
paperweight benchy, right?
yeah, the benchy competition going here.
Yeah, who can print the best benchy? Who can print the biggest benchy?
Yeah.
For people who don't know, the benchy is a kind of landmark, just very strict test piece, calibration piece that has evolved, within the 3D printing, kind of consumer realm, where you set up your printer, and supposedly, the benchy is the first thing you should print because it has all these overhang angles and it's a fairly intricate print, so you can dial in your cooling right away and figure out some issues from the get-go. But you mentioned printing with ABS. I personally have never printed with ABS. I had heard of some of the the horror stories of printing with ABS. Namely, it gives off some pretty nasty fumes, right?
That at that time it was not that obvious that PLA is that better, or the fight was ongoing. I would say it was kind of similarly popular or tested, or it was in the game, and it has some advantages. In terms, you can send it, for instance, contrary to PLA.
Okay.
As far as I remember well, because I'm not using it for at all, and cutting it is different. Like it's more like the feel is different, and a lot of injection molded parts is made of ABS.
Mm-hmm.
So there is a good reason to create models from ABS for the durability, strength probably.
Sure.
But again, printing, the smell of it, and bed adhesion, it's hygroscopic, so it takes a lot of water, and that's also a problem. Well, I went for it because I've read that it's more something probably, and if something is more something, then I go for it.
Right. Yeah,
And
everyone started out with PLA and ABS because, like you mentioned, ABS was used in and is used in injection molded parts. I know too that people like ABS because you can vapor smooth it with acetone.
Exactly, that's it. And I did that, and it works. You can do it in a jar with a vapor of acetone vapor, and it really works. It's hard to control it because you should have a fan inside so that the vapor goes smoothly all around, not too much in one place, because it would be too smooth over there or even destroyed. So you lose your size, precision, and all the details. But yeah, for a statue of a dragon, it may do wonders.
Right. So this initial printer that you were printing with, was it the Ultimaker that was made out of wood originally?
Yes, that was my friend's 3D printer, and it worked and did
Yeah,
work. Yeah, and I printed the parts for the other one. It was called Inventor Bot. You may find
okay.
it on Wikipedia somewhere.
Yeah.
In the end, this did not survive the time, and this idea is not present anywhere in any other 3D printer at the moment.
Mm-hmm. Yeah, I think when we're all getting into 3D printing, the one of the best things to do is to try to rebuild a printer or try to, take a printer apart in aspects and put it back together. I know that's how I learned quite a bit about, the inner workings of the printer. And have a lot of success now rebuilding other printers and maintaining them for that reason. Like we know these lower end printers need some maintenance and TLC as we continue to print with them. So, with that initial printer that were printing out on one printer and building yourself, kind of what was that next stage of, did you then buy a printer? Then did you learn from
Yes,
that and build another printer?
yes, I did in the end. The reason for that was I needed at least three more. And I went for the cheap ones because I thought, well, I do have skills, I can adjust them, I can improve them. So let's buy the cheap ones. And I bought ANET. I don't know how it's called. It was a Chinese version of RepRap, basically, I guess, or Prussia maybe, but no, I think it was a RepRap. It's very popular. These were, and I must say, sometimes we were me and my team we were wondering how is it possible that they still print well, but these printers did their job. There were some problems, especially with the first layer calibration. We had to sometimes just adjust the NEMA motors manually so that during the print in real time. This is not something that should be, it's not
Right.
happening in the modern ones. So yes, that was how I was leveling the bed at that time. But in the end, we did have a lot of success with them, but with the PLA and some simple materials because, well, yes, there was a Bowden extruder there, not the direct one, I think. So, well, these were the ones that I had later. And at some point, I realized that, well, it's not only important to print well, but and it is something that stays with me. You need to be able to replicate what you do, and it's not about having just one piece of some model in your hands, but you have to be able to produce 5 more, 10, and then another one, a different one with support, without support, and then still have a stable machine to print on it, because you lose time and you become more than an engineer than a creator of the object of that part, right? So
Right.
and we went for Prussia. It's from
Okay.
Czech Republic. It's super close to Poland.
Yeah.
Uh,
And they
you
make
know,
wonderful printers. Yeah.
and they do very stable, reliable printers. They also come from the RepRap community, so they know this guy with the hat is very famous, and he was part of the RepRap community, so he was also growing with the community, contributing to this community, and in the end giving back, because what I really liked in Prussia as well, they also came from the open source community and gave back a lot. It changed over the years. Now they're rather a big company and a commercial corporate one, but they did give back to the community a lot. They still have this their models store. Most of the models are free. So yes, and they produce stable, reliable printers. With PLA, you can print a lot with this printer, and we are very satisfied with what they have. We recently bought the latest one.
Okay.
So I
What
can
was
recommend
that?
it. Yes, they redesigned a lot into that, and we did not have a lot of problems with the previous one with this one, but this one seems to be really stable and reliable. And again, this is the feature that I search for most, because it's not about that you have one piece, but it's that you can do it if your company relies on 3D printing, right? And this is the core of your company.
Right. So, your company and mine are very, very similar in that respect, where, we're both heavily into the prosthetic space. We're more so, contract manufacturers where we, take in work orders for practically any 3D printing experience, right? So when you were starting out with just those few printers, is that when you started a company, or you were still just kind of tinkering with those printers? And what were you printing? Were you taking orders?
No. Our story is a little bit different. The 3D printing was the medium to reach the goal, because we started as a company that the goal was to create a robotic, robust, dexterous hand, and we could use 3D printing, of course, but we could be using CNC or whatever. But 3D printing obviously was needed, required, and at the very beginning, the goal was to create the palm of the hand only. So we were not involved at all into sockets, 3D scanning. But then we realized that even if we create the hand itself, then we heavily rely on the existing network of prosthetists, the existing network of of how it's constructed and how it works. But I also wanted to be able to look forward doing something more, and we went into sockets creation, and we had no experience with plaster or whatsoever, but we did have with a lot of experience with mesh design, and we use Rhino a lot, mesh mixer, and all other tools that are needed for that. And yes, now we are doing sockets as well, because thanks to that we can sell the palm of the hand, because we have the medium, the interface to attach it to the body, and that's pretty important in this case.
Yeah. So that was your first product then, getting started with vBionic, was the prosthetic hand?
It was, and it is still the core of the company. We specialize, and we are very professional now, I believe, in upper limb prosthetics. It's not only the palm of the hand. Right now we have different types of
Do you have one of the TOLKAs there?
Yes, I have a lot of. I told this is the prosthesis that, for instance, that we have. It consists of the palm of the hand that is detachable from the sockets. So this is the silicone glove, also produced by us. Yeah, and so the interface is ours. We spent quite a lot of time to create an ecosystem, I would say, that is well, now it's independent, and there are some advantages about it, because we can just like we talked before, we can deliver it to Syria, for instance, to Ukraine, and all parts come from our workshop and our printers. So you have the wrist rotation, and all the joints can be set. So this is TOLKA. This is our basic product. The glove is silicone one, durable. There is a lot of 3D printing involved right here, for instance, and the industry knows it very well, I guess. This is VarioShore, very popular.
VarioShore inner socket. Yeah, very nice.
Yeah, so you can we can create a few with different offsets for the person, so that one day she can use more firmly. The other way, it can be a little bit more loose. It's enough to exchange it from here. We can give 3 or 4 just to exchange it over a day for hygienic reasons.
Okay.
Yeah. So.
Yeah. So for our listeners there, and for people who aren't watching the video here, Bartosz was explaining how their TOLKA arm has these flexible inner sockets that are interchangeable, that can retrofit in when a prosthetic wearer, their limb volume changes over the course of a day or over the course of a week or longer period, where we can retrofit thicker flexible inner sockets into an existing frame, where that person can then continue on to use that prosthesis for a longer period of time. The TOLKA hand, I think honestly is very elegant. It is quite simple in some of its construction, although you don't see all the inner workings there, but all the different joints for the fingers actually articulate right, and that was nice to see that wrist rotation and flexion extension of the wrist as well.
Uh, Speaking about materials and 3D printing, part of it is made of TPU that you mentioned probably recently, and we really like the TPU for these parts because TOLKA is very flexible indeed, and what it makes when force is applied to this device, it won't break because the force is spread along the device. So there is no you can really do harm. You won't harm it, throwing it down or doing some using it in an appropriate way, and it still survives that. And thanks to that, we can be sure that we can give it to the client, and we have almost no service requests for it. Like it just works. It's simple,
Right.
okay. It has its function. It does what it does. But it's reliable, and this is the feature that we really wanted to get because it's important, and it looks pretty well as well because you can
Yep.
choose the color of it, and we even have our own
Right, you can tie the
colors.
silicone to
Yes.
the skin tones. Yeah, that's very nice.
Exactly.
And that kind of swatch of different skin tones.
Yeah.
Very nice. Yeah, and with so how long does it actually take you to go from start to finish of doing any kind of design for it, all the printing, assembly until it's a full device?
The printing, the most challenging part is the socket. Because when we 3D scanned in this or other way, we need to have the 3D scan. Then our prosthetists prepare the test sockets. Sometimes we send them via courier or post, and sometimes we send them to fabrication centers that can 3D print them somewhere, just like we did recently in Turkey.
Mm-hmm.
And when the client says that, well, it fits, it's okay, then we know that we can progress with the TOLKA hand itself. And the production of the TOLKA hand itself, it is a week. It's not a long process because we have everything quite well set, and we have 6 sizes of this hand, and also 2 types: the female and male type of the volume of the palm of the hand. But we also have some already, off the shelf and ready for shipping ones. So we have some stock also for the most common colors, etc. So the most challenging part is communication with the client, honestly,
Right.
because we just ask them, hey, would you send us a video how it looks on your hand, etc., etc. I'm on holidays next week, etc., etc. So if the perfect client would respond in a perfect way, I think within 3 to 4 weeks we could deliver the hand wherever, and that's the maximum time.
Yeah, I think the one of the big impactful things that you mentioned there too is being able to send those files over to another 3D printer that's in a different location, right? So you mentioned sending prints to Turkey.
Exactly. It's for us, it's great that a company like yours just it's interesting and important in our model and idea, because even if we have a client in nearby you, we can in your case you could probably design the socket yourself, because so that's not the case, but for instance in Turkey, in Central America, Africa probably, and elsewhere, this could help a lot. And test sockets can be printed simply in PLA, some simple 3D printer. The good thing is that the socket has to have the correct size, but if it's 0.05 millimeter wrong, then it's still pretty, it still works, right? It doesn't have to be that accurate in this case. Yeah, and when we know that the socket fits well, we can progress, and the rest of the process is created here in Poland, and we deliver the prosthesis via courier. There are some countries that operate logistically better and worse.
Sure.
But in the end, it's possible.
So in your opinion as well, I've also done some of this outreach personally, going down to Port-au-Prince, Haiti, and doing some 3D printing in Haiti with the Haitian prosthetists there, going through a training program on how to use the 3D printers that we brought down there. And so with some of the issues that we face logistically, operating with some of these companies, we have people on the ground who are very enthusiastic and able to operate a printer, see a patient, and, be able to fit a device. However, simple logistics sometimes of getting them enough material, or shipping them a printer. So, with kind of where 3D printing is heading, and where we're heading with the distribution of prosthetic devices globally, this need is only increasing to get to more people in these more desperate, I would say, locations for this type of specialized care, because there's a lack of the specialized individuals to be able to fit these devices anyways. But if we're able to also go in and train them on certain devices like the TOLKA, in your opinion, what are some of those barriers that we're going to have to get through in order to make this fully sustainable in places like Turkey or Syria? Can you speak to kind of some of your experiences in Syria too?
These places are, just like you mentioned, unstable. So we need stable solution, as stable as possible. So the 3D printer has to be stable. When we take it out of the box, it should start working. Right now we have quite a lot of printers that work that way, but still 3D printing requires some assistance from you as well. And when the print is not okay, you have to be experienced in what happens here, because you see very different and crazy outcomes from the printer, and you won't find the solution in the manual, because there are some manuals for some cases, but in the end your experience is required for that. I think we still don't have a printer that you can say that you give it to a person that has nothing to do with 3D printing, is not and doesn't have this engineering approach, because in many cases it's enough your engineering curiosity. Why did that break, right? Then I'm investigating that. But in the case, it should be available and work in a way so that a person that never did that and doesn't care, honestly, because that's the thing for some cases, still can do it, just like ordering some beverage from the machine. Or, well, that's a science fiction a little bit, but in a situation where we could have that in this way, so then we could just focus on design, on creating comfortable sockets and just having them out from some kind of machine. Will that happen? I think yes. Is it happening right now? Not yet, for multiple reasons. So it's more like, if you, as a qualified and certified technician, you can set this type of lab in Port-au-Prince or wherever, but it's still we still need to do more, because it's simply not profitable to open a clinic there. This is not even a bad will of a company, but to set a clinic, you need a lot of money. And for amputations, you would really need a lot of clients, or a governmental project or program, so that you could make this clinic sustainable. And if it's not, then there's no professional, and in the end we have like 20 people, but with zero chance to get the prosthesis there, right? So and in a way we try to cover this problem and this challenge, and try to find a solution for this type of problems as well.
Right. Yeah. I mean, we're trying to start to get into more of that collaboration with other people who actually have 3D printers in these locations already. So we're working with an individual named Taiwo in Nigeria, who
Yeah.
you may have talked with in the past. And the other day, him and I got on a video call like this, and he showed me a supramalleolar orthosis SMO that he wanted to 3D print on his artillery sidewinder. Because I have the same one here in our lab, I was able to help him with some print settings, and make sure that he was going to be printing out the most durable device that I would otherwise print here on mine. I think that's one of the other stepping stones to getting towards making this a little bit more sustainable, is having that interaction where we know that we have the same printers in place, we have tested them already, we can print them just like, I'm sure you have your guidelines for printing the TOLKA hand in other places, right?
You can even share the G code without even the settings, right? If you have just the printer, you can just send the file and it goes.
Exactly.
So yes, that's an interesting idea and an interesting approach. The more sophisticated the hand is, for instance, the more problems arise. So is it but if you could design the socket from the 3D scan coming from Nigeria or somewhere,
Right.
and then a person there has the socket from you and just thinks about the interface later on, what type of hand to attach to it,
Right.
that's 70% of the problem solved, because you
Yep.
really need to have it firmly and comfortable. And then there's the interface, the gripper, let's say. But you can solve 70% of the problem on the way to get the more dexterity in the end, in this way. So it's I think it's very interesting and a good way to progress and to investigate and try to do it simply.
Yeah, we'll see how that develops. I know that you and I had worked on a prosthetic socket that was going to be going to Ukraine for a kind of test fit trial of the polypropylene material for that for the one in Ukraine, right? So that was one test of that that process there too.
If we would create a good pipeline of actions and how to a protocol and a set of maybe printers in multiple places that operate the same way, so that the person doesn't have to be very skilled in this, but just know how to operate it like a TV set or something.
Yeah, just operating the machine.
Yes, then we could probably get new value, new ideas, and new things not available elsewhere. And well, we have the examples of this kind of cooperation recently, just yesterday, we saw Syrian kids that were fitted with the prosthesis that we delivered to Syria, to a war zone, meaning that, if we can deliver to war zone, then probably we can deliver at anywhere, right? That was the challenge that we tried to address and see solution for that. So, so it is doable. Let's progress, right? This is this is the goal of engineers, right? Just to progress and create new things using technology and technical skills and solutions around us.
Right. I know we're both very passionate about this space. In the prosthetics and orthotics industry, being able to provide some of, your 3D printing and engineering expertise and, my clinical expertise too, into some of these places to help further along that type of care, I think is hugely beneficial. And, let's see how that develops, over time. I think we've got a pretty good start to it.
Yes, we do. I guess
there's a lot of need. There's a lot of need in a lot of different places. There are, some organizations who are physically on the ground themselves. We've talked with Ugani, Prosthetics in Kenya in the past, doing some really neat stuff with Blender plugins, and also using artillery, Sidewinder printers, and maybe a couple others. So there's those types of organizations that are on the ground in certain places, and organizations like ours that are trying to do things remotely as most efficiently as we can, while helping to provide that level of training that people would need just to be able to set the printer up and just be able to send them a file like a G code where they can't alter anything, right? So they didn't touch any other print settings to tweak something or make it better in their mind, and something goes wrong, they get a rat's nest, just plastic flying everywhere, and hopefully help to minimize some of those stipulations around like how durable these devices are, in areas like this too, right? So definitely has come a long way, in my experience, over the last 8 years being involved in part of this space, and about the same as yours as well. Getting more into like the nitty gritty of the 3D printing now. So you've used Ultimakers, you've used Prusa. What is your favorite printer? Is it one you've built yourself, or is it a different brand?
It is Prusa, honestly. It does what it should. We modified them a little bit to get them a bit higher because we wanted them to be a little bit higher, but still there is a limit of that. But speaking about height, I just wanted to share some of my latest achievements, because I've been building 2 more printers, and one of them, check this out. This is going up, still up, still up, still up.
That is beautiful.
This is one layer vase. It's not super perfect yet, but it will be very soon. But it's the total height will be like almost 1 meter.
Wow.
Yeah. So this is well, and I did it recently for the reason that we are not limited by the height. I know there are some printers that do that. This is Delta type of printer, by the way.
Okay, a Delta.
Yeah. So I just wanted to share that. But the Prusa is reliable, works well, communicates problems that it has. It's quite easy to service if something happens. But also over the time, at the beginning we used filaments that were cheap, for instance PLA filaments, because it seemed that, well, this is just a plastic, it doesn't really matter. And over the time, right now we are buying a little bit more expensive filaments for the benefit of having a stable solution that doesn't clog the nozzle due to the diameter of the filament. And filaments are also important. So the printer is one thing, but filaments you use also in the end make the printer reliable, because it's not the printer, it's the filament, right? So you also need to have the filaments that are constant in the diameter. That's the first thing, and don't have any dirt inside, and so it's a combination of the filament as well, and the type of material that you use, and also the print. So yes, Prusa is my favorite one, and the rest one was probably we have one Endler. We have one Endler. It's the cubic one, the 30 centimeters. But I guess the first layer doesn't print that well, and it's Bowden. I don't like Bowdens too much.
I like direct drive too, for sure.
Yeah, so
materials.
I don't print a lot with that, but we have it.
Yeah.
Once I created, well, that was my most challenging 3D printer, I guess. I wanted to create a very high temperature one to print with PEEK or even Altem, and it was all metal, water cooled, with the chamber that was heated. That was a challenging thing. I used server box as as the main construction of the printer,
Okay.
and put an all metal Polish design 3D printer inside the FDM1. And well, it did print, but it was not repeatable. It was not constant enough in the prints.
Sure.
And Autumn and Peak are not the materials that I would recommend for for a person that doesn't want to be frustrated sooner or
Right.
later. Because maybe Stratasys printers or bambus. Some printers can print that pretty well, but not mine, and I don't use it anymore.
Yeah.
PEK seems to be, and Altem, a good idea, good printers, good materials, light, durable, not flammable, but it's not the
Right.
most important
Yeah.
feature here.
You
But
really
super
have to have those, industrial applications for those materials for sure.
Yes, in airplanes especially, all the inner walls of the aircrafts are created with PEK.
Okay. Okay. So mainly
It's
for,
light, not unflammable, and yes, that's the reason.
yeah.
So, well, yes, but
Did you recently see that I think it was the Air Force put a 3D printer in one of their planes, and they were printing during flight.
why?
I don't know what they were printing or for what purpose, but they wanted to be able to show that they could do it, that it was possible, I guess. They had it
Then
strapped down with this kind of, the interwoven, like luggage straps over the top of it. And you see this one guy like looking into the printer itself. If I could find that, picture, I'll post it up here. But that was just interesting to me that people are actually wanting to print mid-flight. You know what it was? I think there was it was an application for just forearm to hand splints. If it was a fracture splint in
okay.
like an emergency situation
Oh
where
yes,
they
yes,
wanted
yes,
to print
yes. I've
something.
seen that. I've seen that. Yes, now I remember. Yes,
Yeah, that was
because
their application.
and there was I think there was a DARPA probably project where what they wanted to create was to recreate the parts uh, of some machines in the field that otherwise would be very difficult to deliver there.
Right.
So this is some tiny part that you would have to wait for a week. Then you have the printer. Yes, and it looked pretty yeah, decent
Yeah.
visually. I don't know how about
Yeah.
printing, but it looked, yeah, very military style.
So I mean, that idea of being able to print, kind of on demand in that setting, that's printing up in the air in an airplane. But I guess if we get back to, the application of printing abroad in some of these either war zone or, otherwise low income country, um, so there's a lot of mobile care that happens in prosthetics right now. A lot in the U.S. where they outfit a sprinter van into the backside of it is a lab, has all the grinding machines and tools that you would need. I have had the question once last year, could you put a printer in the back of a van and would it be able to print something quickly enough to be able to, serve that need if you were right there with the patient? So another
Interesting.
interesting thing. Yeah.
Interesting.
But the fastest that we could ever really print something like that right now that I know of is with the Filament Innovations machines with a 2.5 millimeter nozzle. And those machines are extremely robust, and couldn't fit into the back of a rider machine. Yet I might call up Mike Gorski after this and see if he wants to outfit a rider van with one. But printing still a below the knee socket in an hour to an hour and a half. Still, I think in that setting is a little too slow, right? Because if you're in that setting, you kind of want something less than a half hour, right?
Well, I had an idea about having this type of service right at the hospital. Well, after the amputation, the person would come back to the doctor and for checkup, like if it's all okay. After, of course, it can't be right after amputation, but say a few months later, and there could be kind of a box when you just put your limb into, and Ascent Fabrications got the file and come back the next day to take the socket out of it, right? But I still don't think that it is a solution for a well-served communities, well-served countries or regions. But there are some other reasons for that, because Canada, for instance, it's very well established and a wealthy country, but most of the people live on south, right? So you have to travel a lot if you or you face this type of issues, and maybe even it's for rich countries where still that would save some traveling time, like in Sweden, for instance, or Norway, from flying from north of Norway to Oslo or to Stockholm in case of Sweden. That could be also interesting to do it this way, but it has to work, it has to fit, and you know, I'm not that confident with the lower limb, I must admit.
Sure.
Because different forces are applied, it works differently. We are not into that, and I'm not, I don't feel self-confident enough to announce anything about the lower limb, because with upper limb it's different. Anyways, that would be cool.
Yeah. I mean, now that I think a little bit more about it, I guess if you had the intention that, say you were going to a hospital to be able to, go out from your clinic, and you did have one of these, vans equipped with all the other traditional prosthetic fabrication tools that could otherwise help you make adjustments and finish a device. Printing something in an hour and a half, if you're there for the whole day, say you set up a clinic for the day, you're there for 8 hours, you could have a couple sockets printed and fit by the end of the day, right? So, we're definitely getting into some of that on the spot care that would be pretty interesting if if so. I have a contact at the hospital in Ottawa, the Ottawa Hospital. Pat LaBelle, he is a prosthetist that we've been doing some 3D printing with, and they're interested in getting some 3D printers implemented within the hospital. To your point, in Canada, if you outfitted a van to drive up to those patients, instead of those patients having to come down, which it's easier for those more wealthy people to drive out rather than some of those patients to make that trek and drive into those wealthier cities. That'd be a pretty interesting way to deploy something if you could make it efficient and worth the time of everyone.
Yes, I agree. I totally agree. The US and Canada is much bigger than Poland. In our scenario here locally, the patient usually can come to us, but we do have some clients that we served remotely. They did not come here, and they are pretty happy with what they have.
Right.
Yeah, but I'm still thinking about my biggest. Because the market in the countries that are well set, and then where the clinics are almost everywhere, it's more about making it more comfortable for the patients than allowing them to have anything, to have something. I still think that there is an issue with the countries that don't have that much money to spend on it, so you have to reduce the price, but they are not served at all. I think this is we as the company could try to search for to cover this need that exists. With a lot of challenges, including no financial support for that, no funding for these prostheses, but also people who the clients are there. Clients, well, the patients. Sure. So, but it's not profitable to be there and create clinic, because it wouldn't be sustainable.
Right.
That's the area, the remote area, where I think vBionic with the upper limb could fit into.
Absolutely. Yeah, I mean there's a lot of that need, again around the world, and being able to deploy these in a more mobile fashion is becoming a little bit more sustainable. So, definitely interesting to keep up with some of the developments that people are able to deploy, and keep collaborating, right? I mean, this space is still a very young one in the 3D printing industry in general. We're still finding new applications for 3D printing. That may not have anything to do with prosthetics or orthotics, but there are a lot of ways that we can implement it in the P&O field to just be able to do things differently and from a different approach.
Yeah.
With the printing that you're doing, you showed the vase there. Do you also print other things for people that come to you and ask to print other things?
No, actually, we don't, because I think there is a lot of other companies that do it great. We try to focus on the prosthetics, but if we would like to, I think we would be a good point to reach to, because we have a lot of experience.
Sure.
We have some, for instance, I took this one because it looks pretty
Oh yeah, very
interesting,
nice.
right? We received the DICOM files from India just for test, with no comment on what that is. And we created a 3D model out of the MRI scan that was sent to us in the DICOM files. So this is FDM. There were supports there. You can print it. It doesn't look that, it's not. It looks okay.
Nice here. Yeah. What material
Well,
is that? What
Yeah.
material is that?
It's PLA, because it's easy to print, but still you can have something like this. And the thing that I hope to start soon is to a cooperation with a vet clinic that we have very close to our office, because they could send us it is a academic vet clinic, so they have a lot of patients.
Okay.
And different strange patients like elephants and others.
Okay. Yeah.
Yes, so they I know they have some, and they did send me some DICOM files of a cat, for instance, etc., etc. We could just walk a few hundred meters and give them the prints, so that, well, when they have the operation and they prepare for that, maybe we could deliver something. The price has to be adjusted to that. So what I think is important, we should have the 3D printing technology be ready to be just a regular, normal, stable, reliable thing that you just you're not waiting a month for a print and it's not in the news,
right,
that you did at school or something. It's just something that you have, and you can, because it would make it useful in the sense that people would say, well, I can do that because they will deliver it in a day or two. So I can try to do it this way and have this, this possibility. Right now, still 3D printing sounds like, a project, right? We rather than something very easily and cheaply. And for the reason of the cost, I did not mention that we are FDM focused company. We're not using, even though we probably could, we are not using SLS. We had a SLA printer, but I don't like it.
Yeah.
Just for the reason of durability. Anyways, I believe it works for some cases, in our field, not that much. And for the, I have some interesting thing I just wanted to show you today, because
Absolutely.
it's going to the client. This is the final military color filament prosthesis for a person who is a sports shooter. He is well skilled. And unfortunately, he had an accident and he lost both of his hands.
Oh wow!
Yeah. So this, it locks, right? It locks because the type of gun has different angles. I didn't know that because I'm not into guns too much, but it's important to have this possibility. Then we have this very well known type of stripe here that you can lock
Gotcha,
the
strap.
gun.
Yeah.
And well, yes, this is something super cool that you can have only because you can 3D design and 3D print. Otherwise,
Right.
that would not be possible. And it's hard to explain how satisfied this guy is because he was a shooter, then he had this accident, and again he can shoot with his favorite
Right.
gun. I don't know what that is, honestly,
Yeah.
but it makes this is something very rewarding. This is something I really like about this job, that you can work on something that you see really makes a difference. So yeah, that's and the color is cool as well.
Absolutely. I think again for the people who are just listening into the podcast, definitely tune into the YouTube version, so you can see all these very intricate parts that Bartosz has printed out, with this upper extremity prosthesis that's been modified in a very cool design to adapt for this person's shooting needs. So very, very cool. I think it's a wonderful application for 3D printing because we can be so customized about it, and try to give that patient back everything that they were hoping for, right? So otherwise some of these devices might not be as suited for that.
The people have different needs in the end. Not all of them require the dexterity back in the sense that they can wave their hand. Some of them like to do some simple tasks. Now they can't, and they want this task back. It doesn't necessarily mean that you have to give the whole hand back, because it's super difficult to do that. But you can, you can create a custom solution that he can, I don't know, play a trumpet. We did that as well, to hold a trumpet in a hand back again and play a trumpet. And it makes a difference. My vision as a company and a prosthetic devices company is to not to sell the devices more than bring back their their smile or something that they really needed. Of course, the prosthesis, the hand, is the medium for us as well, for sales, for income, etc. But if a person needs a prosthesis for playing golf or something, and that's the thing, we will make the adaptation for that, so that can do it again.
Right.
And this is great about design and 3D printing, and all the materials of the 3D printer sizes and different types of 3D printing that in the end allow us for doing it. And that was not possible just a few years ago. And this is something
Right.
really exciting and cool about it.
Yeah, if it's just been 8 years that we've been in the industry and have progressed this much, what's going to happen in the next 8 years?
Exactly.
With us talking about this type of mobile care in these third world countries or otherwise, in some first world countries, but hard to reach areas. In 8 years, we could be doing that every day. That could be a way of the the pathway that the company could go. So it's we're very fortunate to be collaborating with you, Bartosz. We've definitely had some very cool devices made, and a lot of the impact of being able to share these designs abroad, I think is very, very powerful. So thank you for that. For the past, and we're looking forward to continuing to help get the TOLKA Hand recognized here more in the US and elsewhere, as well as some of the other awesome devices that you're making there too. So great work so far.
Thank you, Joe. I'm really happy that we met at some point, but I think we would met anyways. Like, this is something inevitable, because I think we have the same mindset about what's possible and the same drive to use what's available. So
absolutely, yeah. So with that, kind of getting toward the end of the podcast here, I wanted to mention our tech tip of the week. The tech tip of the week here is focused on actually the print of the week a little bit. So we'll have a video here of the first couple layers of this polypropylene preparatory frame getting into definitive frame, being printed on the Filament Innovations Kratos. with the actual application of bed adhesion. So this tech tip is focused on how we're printing that first layer of polypropylene. So we are using PP Prints Polypro. We personally haven't tested this with any other polypropylene, although I'm sure it would work quite well. We have two different approaches. The approach that you see here on the Film Innovations Kratos has a sheet of build tack, and then we have build tack's polypropylene bond adhesive, a couple layers spread out, that is applied on a cold bed and then allowed to dry before actually starting the print. We will print the first 3 layers at 70 degrees Celsius for the bed temperature. And then we'll turn off the bed after that to help minimize the warping of the polypropylene filament. We also print with a very wide brim, at least 1 centimeter up to 1.5 centimeters. And if we ever have any actual issues with that for whatever reason, you can always tape over the brim, and that will also help minimize some of that bed adhesion. Bed warping or part warping if you have problems with bed adhesion. So that's our tech tip of the week for polypropylene using the build tack and polypropylene bond adhesive. We know that works very well. PP Print has also just come out with a brand new permanently bonded surface to print on. So they have had in the past this rubbery surface. Polypropylene only bonds with itself, so I can only gather that this rubber has some polypropylene in it. And it was a really nice material to stick to. You didn't need any other adhesives. There was a cleaning solution that every 5 or 10 prints, if you had some dust on there, you could clean that off and it would make it as new. And you could use that over and over for hundreds of prints if you were printing, very consistently on it and not damaging the surface. It had a separate adhesive, a 2-sided adhesive that would stick down to the bed, and then the surface would go onto it. The only problem that we've seen with that is that over time, a few prints, because of that warping that happens with polypropylene, it will actually pull the surface up with it. It sticks so well to the surface that it pulls the surface right up from the bed. And I've tried everything to help hold that surface down to the bed. But with this feedback, PP Print has come out with this permanently bonded surface. We do have a few of them in stock now, and they're starting to distribute them out to other locations. Currently, I believe the dimensions are about 305 by 305 millimeters. I'll have to check that exactly, but it's about that size for specifically the Raise 3D style printers for their purpose. They have a very close collaboration with them, so they made it for that printer first. If you have a printer that you'd like that has some different dimensions that you'd like the surface permanently bonded to, definitely reach out to us and we can help you out with that. Bartosz, do you have any other tips and tricks with printing with polypropylene?
I just want to mention that in our case, making a pulse after the first layers works pretty well, and it's needed so that the wrapping is limited. And I totally agree. And I didn't know about the new shield, so I'll reach you or to get one, because we are printing with PP polypropylene, and I think it's very interesting material. It's a little bit more difficult for printing than, of course, PLA, but it has great mechanical features, and it's light. And we even made some, I would say, laboratory tests on shin guards that we create from 3D printing so this is a football shin guard that we did, and we were kicking into that and recording with high speed, high frames camera to see how that works. If somebody's interested, I could share that. And PP polypropylene works well, and it's the best material to go for this solution for us at the moment. So yes, it's
Absolutely. Yeah, if you have that video, definitely send it to me. We'll post it here in this little stint here. I'd like to see how those shin guards do. I think that's a perfect application for the polypropylene. And could you have a scan of the patient's leg? That's an easy way to do it, right? Or patient or customer in that sense, right? You could make them completely custom.
Yes, and we do it for football, so footballists that have only one leg and still
Ah,
play football. So this is all cool. Like,
very cool. Yeah, it all comes full circle back around to prosthetics in some ways. So
yeah, exactly.
very nice. Well, yeah, thank you very much, Bartosz, for your 3D printing insights today, in terms of the printers and tinkering and applications and materials. That's all very useful for our listeners to hear about, some of these trials and tribulations of, how do we get started in 3D printing and what do we use it for,
Mhm.
and how do we implement it effectively. So I appreciate your input and your expertise, and looking forward to working with you more here in the future.
Thank you, Joe, and see you very soon.
Absolutely, yeah. Well, thank you everyone for tuning into the Fabrication Friday podcast. This is Joe signing out. We'll see you next week. Thanks.
Bye.